Welcome to section 3.2, Solve percent applications. Our objective is I can translate and solve applications with interest and markup. So remember our problem solving strategy. It's really important. It's only 7 steps. It won't take us that long. But first we need to read the problem. We need to identify what we're looking for and name it with a variable. Then we'll translate the problem into an equation. We'll solve the equation using algebra techniques. Then we'll check that our answer makes sense. And finally, we'll answer the question with a complete sentence. We're going to follow this same pattern over and over and over. So let's try this first one. Let's translate and solve. What number is 35% of 90? And you're saying to yourself, wait a minute, I've done this before, I can do it. But part of it is we're going to practice using our problem solving strategy. So first thing we need to do, read the problem. We're looking for what number is 35% of 90. So we're looking for a number. Let's give that number a name. I'm going to give that name n. N for number. So the number I'm looking for is n. Next, we're going to name, so we've named what we're looking for. Let's translate it into an equation. What number is usually a giveaway for equals. 35% of usually means times 90. Okay, 35%, I don't know how to multiply by percent. So I need to convert that to a decimal by moving the decimal point 2 places. So that'll give me n is equal to 0.35 times 90. 0.35 times 90. If I pull out my calculator, one second here while I grab it, 0.35 times 90 is what I want to do. .35 times 90, I get 31.5. I get 31.5. Does that make sense? Does our answer make sense? Yeah, I would say it makes sense. 35% is about 33%, which is about 1/3. And 31 is about 1/3 of 90, so I think it makes sense. Now let's answer with a complete sentence. The number is 31.5. Okay, I've done one. Now it's time for you to try one on your own. Pause the video, and I'll see you in a second. Okay, now that you've done it on your own, let's do it together. Let's translate this and solve. 6.5% is of what number is $1.17? So once again, I'm going to use n for what number. So let's set up our equation. 6.5% times n, I'm going to use parentheses this time just for fun, is equal to 1/17. Okay, I'm going to convert my percent to a decimal. So that'll be 0.065 times n is equal to 1/17. If I divide both sides by 0.065, because I'm going to divide by whatever's attached to my n, I'll be left with n is equal to 18. So does it make sense? 6.5% of what number? 6.5% of 18 is $1.17. I believe it. I believe it. So now let's answer it with a complete sentence. The number, I guess we're in dollars, is $18. Okay. Blake and Carlos enjoyed a nice dinner at a restaurant, and their bill was $68.50. They want to leave a tip that is 18% of the bill. How much tip should they leave? Oh, great question. Okay, so remember we're using our problem-solving strategy, so we've already read the problem. We're looking for the tip amount. So I'm going to use T to equal the amount of tip. Okay, so let's see. I know that, I know that, let's see, the tip that they want to leave is going to be 18% times 6850. That makes sense to me. Okay, so now let's solve that equation. I'm going to convert it into a decimal by moving it to the decimal 2 places to the left. And I'll get 0.18 times 6850. And 0.18 times 6850 happens to be $12.33. So, does our answer make sense? Does it make sense to leave a $12 tip on a $68 meal? I believe so, because it is a pretty nice restaurant. So, let's write our answer in a complete sentence. They leave $12.33 as a tip. Okay, we did one. Now it's time for you to pause the video and try this one on your own. Now that you've done it on your own, let's do it together. Josh had lunch at his favorite restaurant. He wants to leave 15% of his total bill as a tip. If his bill is $14.40, how much should he leave as a tip? Okay, so we're looking for the amount of the tip, so I'm going to use T again. T for tip. So he wants to leave 15% of the bill. So let's see, 15% times 1440 is equal to the tip. So let's move our decimal 2 places and multiply. So 0.15 times 1440 is $2.16. Does it make sense that we would leave $2.16? I think so. So he left $2.16. Okay, Betsy received some gourmet brownies as a gift. The wrapper said each brownie was 480 calories and had 240 calories of fat. What percent of the total calories in each brownie comes from fat? Oh, interesting. So it looks like we're looking for the percent. So I'm going to use P to represent the percent of fat. So let's set up our whole thing. I know that, let's see, 480, the total times the percentage from fat will equal the amount of fat, calories from fat, 240. So how do I solve this? Well, I'm going to divide both sides by whatever's attached to my variable. 480 divided by, 240 divided by 480 is in fact 0.5. It's 0.5. Well, 0.5 is equal to P. Am I done? No, because I found a decimal and the question asked for a percent. So I need to move my decimal 2 places to the right and slap on a percent sign. So I'll get 50% of the calories were from fat. 50% of the calories were fat. Go ahead and pause the video and try this one on your own. Okay, now that you've tried them on your own, let's do it together. So we read it, and we're looking for the percent again. I happen to use P for the percent of fat. So let's do it now. So looks like the total is 190 calories, 76 are for fat. So I'll go 190 times P is equal to 76. Divide both sides by 190. What will I get? P is equal to 76 divided by 190. Happens to be 0.4. Happens to be 0.4. But I'm not looking for 0.4. I need to move the decimal 2 places and slap on a percent sign so that I get 40%. So 40% of the calories were from fat. In 2011, the California governor proposed raising community college fees from $26 a credit to $36 a credit. Let's find the percent increase. And we'll round to the nearest tenth of a percent. So how do I find percent increase? Well, you may remember from before that a new amount, the new minus the original, will equal the increase. You say, well, I mean, that's of course pretty obvious. So all we have to say, what was our increase? Well, our new amount is 36. Our original amount was 26. That means that our increase was $10. We went up $10. Now we want to find the percent increase. I'm going to use P again to represent that percent increase. So what I'm asking is 10 is what percent times 26? So we have an increase of 10. We have an increase of 10. And we want to say 10 is what percent of 26, our original 26. So if I divide both sides by 26 to get P all by itself, I'll get 0.384 is equal to P. Let's convert that to a percentage, and I'll get 38.4% is equal to P. So our percent increase, it increased to the nearest tenth of a percent, well, 38.4%. Once again, go ahead and pause the video and try this one on your own. Now that you've tried it on your own, let's do it together. The average price of a gallon of gas in one city in June 2014 was $3.71. The average price in that city in July was $3.64. Let's find the percent decrease. So just like before, the percent decrease, we need to find the overall decrease first. So we'll have, interesting, we'll have the original minus the new this time to find the decrease. So that means that we'll have $3.71 minus $3.64 will be equal to a 7-cent decrease. Okay, so now we have to ask 7 cents is what percent of $3.71. So just like you did, I'm sure, you got 0.07 is equal to P times 3.71. I divide both sides by 3.71, divide by 3.71, and I'll get P is equal to 0.019, which if I move my decimal 2 places to the right, I'll get 1.9%. So there was a 1.9% decrease. The next thing we care about really is interest. So we're going to be looking at this simple interest formula. When you put money into banks, of course, you can be paid money. We call that interest. The interest is computed using the original amount that you put in, called the principal, and it's with a P. We usually use a capital P to represent that. The interest rate, R, and the time that the money is invested, T. And we get this formula. The interest is equal to the principal times the rate times the time. Simple interest. I is equal to PRT. Very important if you want to live your life in the modern age. So let's take Olivia, for instance. Olivia deposits $12,500 in her bank account where it will earn 4% interest. How much interest will she earn in 5 years, you may ask? Well, this is a pretty important question. So we just need to remember our formula. I is equal to P times R times T. We're looking for the interest. What else do we know? Well, we know that she's going to do it over 5 years of time, which lets me know that I'm going to use T is equal to 5. I know that the interest rate is going to be R, and it's 4%, but I need to turn that into a decimal. So I'm going to move the decimal 2 places, and I'll get 0.04 as the rate. And the original amount that she put in is $12,500, which means that's going to be my P. So now let's throw everything into our formula. So the interest that she's going to earn is equal to 12,500 times the rate, which is 0.04, times the time, which is 5 years. And if I type all of that into my calculator, I type in 12,500 times 0.04 times 5. That tells me that she will make, after 5 years, she'll make $2,500 as the interest. So that's what I'm going to write down. I'm going to write she earns $2,500. Go ahead and pause the video and try this one on your own. Okay, Isabel invests a principal of $950 in her bank account with an interest rate of 3%. How much interest did she earn in 5 years? So I have the time, I have the rate, which I can convert into a decimal, and I have the principal. So now I need to use the formula. I is equal to P times R times T. And let's put them all together. The interest is what I'm looking for, is equal to P, which is 950, times R, which is 0.03, times T, which is 5. And I can type all of that into my calculator. And I'll get $142.50. Maybe I made a mistake. Let me double check that. 950 times 0.03 times 5. Nope, did it correctly. Excellent. So, Isabel earned $142.50 in interest. Layla loaned her teacher $3,000 to help them buy a car. Oh, that was nice of her. In 4 years, her teacher paid her back the $3,000 plus $660 in interest. What interest rate did she charge? Oh, this sounds like a pretty important thing. Okay, so let's see what we know. We know that the original amount, the principal is $3,000. We know that the time was 4, and we know that the interest is 660. So let's see. I'm going to plug them all into my formula. Remember, it's I is equal to P times R times T. And let's see what variable we need to solve for. So I know that my I, that's 660, is equal to 3,000. I don't know what R is, so I'm going to just write it again, times 4. Okay, so let's simplify a little bit. Those barriers aren't doing anything for me. 3,000 times 4, that's 12,000 times R. I'll divide both sides by 12,000 to get R all by itself. And when I put that into my calculator, 660 divided by 12,000 is 0.055. I move the decimal 2 places, and I find that Layla offered her teacher a loan at 5.5%. So she loaned at 5.5%. Excellent. Thanks, Layla, for doing that. I really appreciate it. Go ahead and pause the video and try this one on your own. Now that you've tried it on your own, let's look at it together. Brooke noticed that her new car loan papers stated that with a 7.5% interest rate, okay, so we know that R is equal to 7.5%, which we know is 0.075. She would pay $6,596.25 in interest. Okay, so I know that my interest $6,596.25 over 5 years. So I know that T is equal to 5. How much did she borrow to pay for her car? Well, I is equal to P times R times T. So 6,596.25 is equal to the principal times the rate, which is 0.075, times the time of 5 years. So let's simplify a little bit to make it a little bit nicer. 5 times 0.075 happens to be 0.375. 0.375 times P is equal to 6,596.25. I'll divide both sides by 0.375 to get P all by itself. And I'll get 17,590. Wow, that's a pretty nice car, Brooke. Good for you. 17,590 is how much she originally spent on the car. The one last thing we're going to look at is called the discount rate. It's usually given as a percent and used to determine the amount of discount. So when you go to a store, for instance, the amount of discount you get is the discount rate, which is usually a percentage, times the original price of the item. So the sale price is the original price minus the amount of the discount. So we're going to use these to our advantage. For instance, Amanda bought a dress that was discounted 35% off of the original price of $140. What was the amount of discount and the sale price? So, first thing I need to find out is how much money did she get? What was the amount of discount? So, we know that the amount of discount is equal to the sale price, or excuse me, the discount rate times the original price. So let's find that. Well, our discount rate, if I move the decimal, is 0.35 times the original price of 140 is equal to the discount. I'll use a capital D to represent the discount. So the discount that Amanda got is 0.35 times 140, $49. Wow, she got a dress that was $49 off. That's pretty nice. Excellent. So what was the sale price? Well, then once we get to the register, they will find the sale price by taking the original and subtracting the discount. So the original was 140, and we subtract off the 49 from the discount. So our sale, we got it on sale, $49 off, otherwise known as, not 99, that's not right at all. 140 minus 49 is 91. Our sale price, $91. Go ahead and try this last one on your own. I'll see you in a second. Now that you've paused the video and tried it on your own, let's do it together. Dylan bought a barbecue that was discounted 65% from an original price. What was the amount of discount and the sales price? So, the amount of discount is equal to 65% as a decimal times 395. If I do that, 0.65 times 395 is equal to $256.75. That's pretty nice. That's pretty nice indeed. So then how much did he actually pay? Well, the sales price is equal to the original minus the discount. So our original was $395 minus the discount of $256.75. And what will I get? Well, the amount he actually paid is $138.25, which is a pretty great deal if you ask me. Thanks for watching, and I hope to see you soon.